Okay, this is the second part of Chapter 5, and Gregory Mankiw, microeconomics, and we're talking about elasticity. In this chapter, in this section, we go very specific into the nitty-gritty of calculating elasticity. And as you'll find out, there are three methods of calculating elasticity: percentage, midpoint, and total revenue. This is the percentage method. As you can see, the formula, percentage change in quantity demanded over the percentage change in price. Let's look at an example. Example, if the price of an ice cream cone increases from $2 to $2.20 and the amount you buy falls from 10 to 8, then your elasticity of demand would be calculated as, and here's the formula, here's the answer. So we look at the quantity demand first, 10 minus 8, so that is the change, and then making it a percentage change, we do that over the base, and we start from 10, so 10 minus 8 over 10 times 100 equals 20%. That is over the percentage change in price, $2.20 minus $2 over $2, since that is the base, times 100 equals 10%. 20% over 10% gives us an answer of 2. And what this answer means is, given a change in the price of 10%, the amount that people responded, and negatively in this case, was 20%. So our answer is 2. And this definitely makes this item a want as opposed to a need. Okay, so this is one method called the percentage method. Now, one of the issues with the percentage method is if you change the base, like if we did 8 as opposed to 10 and 220 as opposed to 2, you would get a different answer. So since we're dealing with the same range, that we really shouldn't get a different answer. So economists have come up with a method known as the midpoint method. It's a better way of calculating percentage changes in elasticities. The midpoint method is preferable when calculating the price elasticity of demand because it gives the same answer regardless of the direction of the change. Now here, this monster is the midpoint method. The only thing that's really changed is the base. We still have the change in quantity, but now that change is over the midpoint, which is Q2 plus Q1 over 2. So let's say we were doing the, well, I think we'll do it in the next couple of slides. It would be 10 plus 8 divided by 2, which would give us 9. So it's the midpoint in the range of the two numbers. Same thing with price, change in price, and then this whole thing over the midpoint. Now I think the next slide is going to have an easier way of looking at this. Here's a better and simplified way of looking at the midpoint method formula. It's the change in quantity demand over the midpoint all over the change in price over the midpoint. So you don't need to look at Q1s and Q2s and P2s and P1s. Just keep in mind the simple little rubric, as it were, and you'll be able to calculate these problems just fine. Okay, so here's an example of the midpoint method. We have the same range. If the price of an ice cream cone increases from $2 to $2.20 and the amount you buy falls from 10 to 8, then your elasticity of demand using the midpoint formula would be, now we've got 10 minus 8, but now it's going to be over the midpoint, which in this case will be 9. 10 plus 8 divided by 2 is 9. And then 220 minus $2 over the midpoint, which I think is $2.10, would be 9.5%. And our answer, very close to the percentage method calculation, is 2.32. The real advantage of this method is that you get the same result regardless of whether it's an increase or decrease in the price, because the base does not change at all. And there's some major determinants, one being necessities versus luxuries. This is what makes it either elastic or inelastic. If it's a necessity, it's going to be inelastic, a need; luxury, elastic, a want. Availability of close substitutes. If there's a lot of substitutes, then it's going to be a want. You don't necessarily need it. Very few substitutes is going to be a need. Definition of the market. Now, what does this mean? This means less specific to more specific. If the categorization is less specific, like food, that is going to be more of a need. It's going to be more inelastic. If it's more specific, like a type of food or a brand of a food, is going to be inelastic, and it's going to be more of a want. Finally, time horizon. Time horizon goes from more to less flexible. If you are more flexible in your time to buy the product, your demand is going to be more of a want, and it's going to be more of a luxury. It's, basically, if you can name your own time and you're flexible, it's not going to be nearly as much of a need, and you can wait for a lower price. Now, if you're less flexible, that definitely means that is more of a need. You're going to be subject to a much higher price. Airline companies are very, very good at figuring out what the time horizon of their flyers are, so that they can engineer a price based on your willingness to pay, your need to be at that particular place. Greater the need, higher the price. Less great the need, lower the price. All right, let's get more specific here. Demand tends to be inelastic if the item is a necessity or a need. If the time period is shorter, you're not as flexible. There are a small number of close substitutes, and the market is broadly defined. So the market is less specific, not more specific. Now, demand tends to be elastic if the good is a luxury or a want. If there is a longer time period or the person is more flexible, there is a large number of close substitutes, and the market is more narrowly defined, more specific. Brand specific, that is. And the consumer doesn't really see a difference in the brands themselves. Now, you can draw a graph on your own. I'm sure the Manku book has this on various types of elasticity, but we're going to go through it now on the show here. Right. Before we do this, let's look at these types of goods. Which good would be expect to be more elastic and why? Let's do the first one, and that first one is going to be required texts or mystery novels. Which one is more elastic? If you guessed mystery novels, you are correct, because mystery novels have a lot of substitutes. They are not necessarily a need. How about business versus vacation travel? If you guessed vacation travel, you are correct. Definitely the person is more flexible. Definitely the person doesn't have to be there. A business traveler absolutely is going to be more in elastic demand. An iPhone for the next 6 months or for the next 5 years? Hopefully you guessed the next 5 years, because the person, well, it's a bad zero there, because the person is going to have more flexibility, and there's probably going to be more substitutes out there. Pepsi or soda in general? Pepsi absolutely is going to be more elastic just because there are more brands out there. As a matter of fact, I'm drinking a Coca-Cola right now, but I can be drinking any number of sodas. So the elasticity is going to be greater for Pepsi relative to soda. Okay, let's go on to ranges of elasticity. Inelastic demand. Now we're getting more technical. Quantity demand does not respond strongly to price changes. Price elasticity of demand is less than 1. And we have perfectly inelastic. Elastic demand. Quantity demand responds strongly to changes in price. Price elasticity is greater than 1. Perfectly inelastic. Now we're going to see some pictures showing this in words. Elasticity equals 0. This is perfectly inelastic. Change in price leads to no change in quantity demand. Oftentimes that happens for things that are needs in certain price ranges, but as the price goes up, the person is going to find that it's not as much of a need after all, and their quantity demand will change. Next example, steep but not vertical. We have inelastic demand, elasticity is less than 1. We have a change in price that leads to a small change in quantity demanded. So while for an individual they may have perfectly inelastic demand, let's say for gasoline, market-wide, the increase in the price will lead some people to drop their quantity demand and other people to still consume. So overall, the increase in price is going to lead to some drop in quantity, but not as much as the increase in price. Alrighty. Unit elastic demand. This is a special case where the increase in price leads to exactly the same drop in quantity. Rarely see this in the real world behavior-wise, but that number 1 is very important because it is the measuring stick by which anything above 1 is going to be elastic, anything below 1 is going to be inelastic. And this is the case of the elastic demand curve. Here we have an increase in price leading to a greater drop in quantity. So this might be for a particular brand of coffee. Let's say Folgers went up in price and none of the other coffee brands went up in price. You say, I can drink U-Band just as well, so you drop your quantity of U-Band entirely. And so there's going to be a greater drop in quantity relative to the price. Of course, manufacturers and marketers don't want to see this, so they want to have in the consumer's mind that they need this particular product. Alright, finally, elasticity equals infinity. Any price above $4, quantity demand is equal to 0. Consumers will buy any quantity at this price. Price below $4, quantity demand is infinite. This is the opposite of the vertical demand curve. This is a situation where you can sell any amount you want at the given price, but you have no power whatsoever to raise the price, nor do you want to lower the price whatsoever. We will see this little demand curve again in perfect competition. That would be Chapter 14, a couple of chapters from now. I believe this ends